This is section 4.7, isometries. So what an isometry is it's a transformation that is either a reflection or composite of reflections, so like multiple reflections back to back. So we have different options here. We could either have reflections, so just a straight flip. We could have a rotation, which would be reflecting over two lines that are crossing each other, so reflecting over two intersecting lines. We could have a translation, which would be reflecting over parallel lines, or we could have a glide reflection, which is a new one for us. But a glide reflection is some type of movement that doesn't really, it's not just a reflection, not just a rotation, not just a translation or a slide. It's actually kind of a combination of those things, where it couldn't be classified as either of those three. But we'll talk a little bit more about glide reflections in a little bit. Okay, so what we're going to focus on today is reflections over three lines. So before we did just, a straight reflection over one line. Then we got it over when we started going over parallel lines, so that was two reflections. And then we went into intersecting lines, which was also two reflections. So now we're going to get into where it's three lines. Okay, so how this is going to work. Orientation, so clockwise, counterclockwise, has to be reversed. Okay, so it's not going to stay the same. It's going to switch to the opposite of whatever it is because there's an odd number of reflections. So if we do one reflection, it's going to switch. We do two, which would be an even number, it switches back to the original. So then if we do three, it's going to switch again. So since it's an odd number of reflections, it's going to be reversed. And this also means that it can't be a translation or a rotation because those both preserve orientation. Okay, so it would basically either be a reflection or a glide reflection. Okay, so what we're going to do is we are going to look at four possible cases here of different situations we could have when we're reflecting over three lines. They're classified by how many points of intersection they have, and there is a little printout for this as well, so it should look something like this. You would want to print that out or have that somewhere so you can make reference to it while we're talking about this. Okay, so the first one here is case 1, where it would have 0 points of intersection, and if there's 0 points of intersection, that means all three lines have to be parallel with each other. What this is going to look like is one reflection is the same as our picture here. So the picture that's on the printout only has these two pictures here, but what I went and did is I added in the extra pictures there for the second and the third, just because I feel like it's a little bit easier to visualize doing that. Okay, so what we want to look at here is this picture here is our original, so A, B, and then there's C there and the D, but A, B, D as a triangle. And what we're going to do is we're going to do some reflections with that. So it's a composite of reflections where we've got three happening here, and we're always starting with the one that's furthest to the right. So the first one that we went and flipped over here was the L. And I just sketched that in. I didn't measure it or anything like that, just for the purpose of talking about it. So we took this one here, the original triangle, flipped it over L, so that takes care of that. Then we take this triangle, which would be like the prime triangle, and we're going to flip that one over M, which is this line here. So when I take that one and flip over M, I get to the third one here, and then I'm going to take that one and I'm going to flip that over N. And that's how I end with that one there. So that would be flipping over these three lines here, and none of them are crossing, so it would be 0 points of intersection, which would be our case 1 here. And then what they want us to get out of this is it looks the same as if we just did one reflection. So if you look at your first picture and your last picture here, 1 and 4, those look like they're a reflection of each other. And they're going to look like they're a reflection of, let me get a highlighter here. They're going to look like they are a reflection over that line P. Okay, so we'll kind of write this out here. They write it out like this, so they go, okay, this one here, flipped over P, gives us this one here. They write that, and I'm also going to write that this is the same as a reflection over line P. So that there is the same as a reflection over line P. Okay, so if we do, 3 flips over 3 parallels, it's going to look the same as just 1 flip. Okay, and that's over that line P there. So I'll highlight that because it kind of goes with that P. Okay, so that's if all three lines are parallel. It ends up looking the same as a reflection. The next one here is if we flip over three lines with one point of intersection. So if I go back here to case 2, 1 point of intersection, so the three lines are concurrent, or that means they meet at a single point. Okay, and this is going to look like one reflection is the same picture. So again here, they just give us the first and the last. I filled in like the second and the third with just sketches here. So basically what they want us to do is they want us to do a reflection over S, and then T, and then V. So if we look through our pictures here, a reflection over S would be this one flipped to this one. Then we're going to take our second picture, reflect that over T, which would get us to this one. And then we take our third picture and reflect it over V, which would get us to this one here. Okay, so now if we are comparing the first picture and the last picture, really those look like they're a reflection of each other, right? And this time it's going to be a reflection over this line Q here. So I would write this stuff in here about it being the composite of reflections. So all of those three reflections there over three lines that intersect in one spot is going to look at the same as just one reflection over this line Q here, and we'll write that in. Same as a reflection over line Q. And that line Q is what's highlighted there. Okay, so if we flip over lines, three lines that cross in one spot, it's also going to look like a reflection from the first picture to the last picture. Okay, now we'll take on case 3 here. So if I look at case 3 in my notes, case 3 has 2 points of intersection. Okay, so when we set this up, 2 of the lines have to be parallel to each other, and then the third line intersects the other 2. So it's kind of like having 2 parallel lines and then being cut by a transversal line. Okay, and that's the only way to set it up with 2 points of intersection, is to have 2 parallels. And then what we've also got there is it's going to be a composite of reflections that is either a translation and a reflection, or a rotation and a reflection. Okay, so this would be considered a glide reflection because you have to do multiple movements and you can't just classify it as one. So let's look at that here. So here they actually did give us all 4 pictures, which is nice. So our original picture here is the pre-image, this one here. Then we are flipping, so we're going this way, starting with the one that's furthest to the right. So we're starting by a flip over M, so we go 1 to 2 with the flip over M. Then we flip over N, which would get us to the third one, and then the third one flips over P, which would give us the fourth one. So this is our first picture, this is our fourth picture. So now when you're looking at those, you can't really describe the movement from 1 to 4 as just one thing. You have to describe it as 2 movements, okay, because this is what a glide reflection is. So there's 2 ways we could talk about this. We could either talk about it as a translation and a reflection, or a rotation and a reflection, just kind of depending on what we're going with here. So here, this one that's actually listed would be a translation. So like if you look from 1 to 3, since we're flipping over those 2 parallels there, we know reflecting over parallels is going to give us a translation, which you can see here. Then after we translate it or slide it down to 3, it's going to take and flip to get to 4. So that would be a translation or a slide there, and then a flip. So this is a glide reflection. So I'm going to write translation followed by a reflection. And this happens when we flip over the parallel lines first. Okay, so if you flip over your parallel lines first, it's going to look like you took and slid that and then flipped it. So this matches with exactly what happened on that one there. Now there's another way to think about this too. We could also think of this as if we flipped over the intersecting lines first. So say you flipped over like P and M first as your first two, where if you flip over intersecting or crossing lines, then it's going to end up being a rotation. So that would be a rotation, and then we would have our reflection. So it would be a rotation followed by a reflection. Okay, so let me write this down here. So rotation followed by a reflection. And that would be when we flip over our intersecting lines first. Okay, because the intersecting lines will give us that rotation, and then the other line that's there will give us the reflection. Okay, that one a different color here. And this would be like if we did R, or reflecting over N, followed by a reflection over P, followed by a reflection over M. Because these two, the ones that we would do first, are M and P, which are crossing lines. So that would go with rotation followed by reflection. Okay, so that picture's not listed there, but that could also happen with two lines like this. Okay, and then the last one, they don't put a picture with this, not sure why, but this is when we flip over lines that connect in 3 points, so like 1, 2, and 3, so this is case 4. So if we look back at our notes for case 4, 3 points of intersection, and it's always going to look like that triangle shape, because that's would be crossing in 3 different spots. And then it says no matter the order of composing reflections, the results are always going to be a rotation followed by a reflection. So this one is also going to end up being a glide reflection, but this one we can't have a translation in it. It's always going to be a reflection and a rotation. Reason being is here, for the case 4, we don't have any parallel lines. So we can't have a translation if we're never flipping over parallel lines. So this one, no matter which order we go in here, is always going to be a rotation followed by a reflection. And the reason for this is all lines intersect. Okay, so we don't have any parallels basically, so that's why we can never have a translation. It's always going to be a rotation followed by a reflection. Okay, so that's that. So we'll go back here to our cases. So this also says here that case 3 and 4 cannot be described in terms of a single reflection. So it's either, you know, a rotation and a reflection, or a translation and a reflection. We have to do multiple things to get there. So what we do is we call this a glide reflection. Okay, so we can't get there in a single movement. We got to do multiple things. So we call that a glide reflection. And that's actually our next definition here on page 225. So if you look on page 225, you can see that definition. So it says, let the reflection over M be the reflection, and T is the translation with non-zero magnitude and direction parallel to M. Then G is equal to T, and then the composite, or G is equal to T, followed by the reflection over M is a glide reflection. So that's kind of a confusing definition there, but basically what it means is you just have to do a translation, so like a slide or a rotation, and then a flip following either of those movements. Okay, some other stuff that goes with glide reflection. So it kind of just says the same thing I said there about, you know, flipping over parallels or intersectings. And then the next thing here is it's going to preserve angle measure, betweenness, collinearity, and distance. So it's going to preserve those ABCD things, but it is not going to preserve orientation. So our orientation, so clockwise, counterclockwise, is going to switch because we're doing 3 flips here, which would be an odd number of flips. Okay. And they have a pretty good picture of an example of something that would be a glide reflection on page 225. So if you look on page 225, I'll put it up here for a second. Basically what they've got is they've got some feet here, and if you think about feet, like this foot and this foot, if you're standing like right, you know, shoulder width apart, that kind of thing. Your feet are reflections of each other, where, your big toe's on the inside of each, and then, your heels here, pinky toe. Your feet are reflections of each other. So what happens when you walk is, say this foot slides forward here, that would be like a translation, and then this other foot, if that kind of flips over there, that would be like a reflection. So they're reflections of each other, and then also a translation. So walking, or like kind of gliding with your feet, is considered a glide reflection. Okay, so that's just one example that you might see that. Okay, and then the next thing here, a composite of reflections in a plane is always either a reflection, rotation, translation, or glide reflection. So those are the only 4 isometries that it could possibly be. It can't be anything else besides those 4 different terms. Okay, so we got some pictures then on your example sheet here. So it should look something like this. So we're going to look at these. So it says identify the isometry that maps one image onto the other. So it basically has to be classified as either a reflection, rotation, translation, or glide reflection. Those are our only 4 possible answers here. So if I'm looking at this first set of flags, I want to figure out first if I can get there in one movement. Okay, so if I'm looking at this flag to this flag, if the first thing I'm thinking of is reflection, well, if I take this one and flip it over this way, the flag would be kind of up here somewhere. If I took the flag and flipped it over this way, it would be down here somewhere, so it can't really be a reflection. Next one I would go to is rotation, and a lot of times people think this one is a rotation, but if I actually took and turned this flag, the stick part of the flag would actually be facing out the other way. So if I actually did a rotation of this, the pole of the flag would be there, and then the actual flag would be going this way, which isn't what's happening here. So it's not going to be a rotation. Next one is translation. So if I took and slid this flag, it wouldn't look like that picture there, so it's not a translation. So it must be a glide reflection. So I'll write that in, glide reflection. Okay, and then how I would actually get there is I could think about, if there was some line here, if I flip that over, I would get a picture like that, so that would be like my reflection to get from that to that, and then to get to this one here, it would be like a slide. So I'm basically taking and flipping, which would be my reflection, and then I'm sliding, which would be a glide reflection. Okay. Okay, and then the next one here, same thing, identify the isometry that maps this one onto this one. So this one going through my things, not a reflection because it's not being flipped, it's not being turned, so it's not a rotation. Translation is a slide. Well, it does kind of look like I just took and slid this, right, to get from this one to this one. Looks like I just slid that flag down there, so I would go with translation for this one. So anytime it asks for an isometry, it's just one of those 4 things, either reflection, translation, rotation, or glide reflection. Those are your only 4 possibilities. Okay, so that is the last thing on the notes. So your book page assignment is 227, 1 to 6 all, 8, 9, and 12.